Man at all is the eighth wonder of the world. It's one of the most amazing megalithic sites that I've ever seen.
Experts said that artificial intelligence is doing more harm than good to humanity. Predictions reveal that in no less than a decade, AI will not be used by people anymore as it lacks human touch and the tiniest of details we're all looking for. But what if you discovered that hundreds of thousands of years of problems were solved in minutes or just days through it? Today, we'll get to witness how AI decoded ancient language, and the revelations exposed will terrify you. Number 20. AI deciphers Enigma code in 10 minutes. During World War II, German forces relied heavily on a sophisticated cipher device known as the Enigma machine. In an era where even the slightest information leak could shift the balance of power in battle, the confidentiality of each message was paramount. Originally designed by Arthur Scherbius in the 1920s for commercial purposes, the Enigma was swiftly adopted by the German military for its strategic advantages. The Enigma machine operated by converting messages into what appeared to be unbreakable codes, utilizing a complex arrangement of rotors and electrical circuits to scramble the information. Each keystroke would substitute one letter for another, with the machine's rotor settings ensuring that the encryption was in a constant state of flux. This intricate design made it incredibly challenging to decipher, as the machine could be configured in trillions of different ways. Only another Enigma machine had the potential to decode the messages, or so it was believed until recent advancements. AI has achieved the remarkable feat of deciphering the Enigma code in just over 10 minutes, a task that once took Alan Turing and his team at Bletchley Park days or even weeks during World War II. In 2017, the Enigma pattern team utilized the capabilities of 2,000 virtual servers to explore every possible Enigma configuration, processing an astonishing 41 million combinations every second. They trained the AI on Grimm's fairy tales to help it recognize patterns in the German language, enabling it to swiftly determine the accuracy of a decryption based on linguistic nuances. This innovative approach allowed the AI to crack the Enigma code in a mere 12 minutes and 50 seconds, a breathtaking contrast to the months of laborious effort required in the past. The AI successfully decoded the four-rotor Enigma, the most intricate version employed by the German Navy, highlighting the incredible advancements in technology. Number 19. A mysterious script used by the ancient Minoans. There's no doubt that if Linear B exists, Linear A must be part of the story too. You might be curious about the origins of its name and the relationship between the two scripts. Linear A was the writing system employed by the Minoans on Crete, while Linear B, a derivative of Linear A, was utilized by the Mycenaeans in mainland Greece. Both scripts were uncovered in 1900 by Sir Arthur Evans. Linear A dates back to between 1800 and 1450 BCE and was mainly used for administrative and religious documentation. Although it shares similarities with Linear B, which has been deciphered as an early Greek form, Linear A remains a mystery. This is primarily due to the unknown language it represents, leaving researchers without comparable languages or scripts. However, the landscape is changing thanks to advancements in AI and machine learning. Teams from institutions like MIT and Google's DeepMind are leveraging AI to explore Linear A in innovative ways. By training neural networks on established scripts such as Linear B and other ancient languages, these systems can uncover patterns and connections between symbols that might elude human analysis. The AI's capacity to swiftly process large datasets and recognize linguistic structures has already led to significant insights, particularly regarding numerical systems and frequently used symbols in Linear A. As AI technology progresses, there is growing optimism that it may one day unlock the secrets of Linear A. Are you starting to get fascinated? We're just getting started. Number 18. Using artificial intelligence to read the Vindolanda texts. Unearthed from the ancient Roman fort of Vindolanda, located near Hadrian's Wall, the Vindolanda tablets are delicate wooden artifacts inscribed with handwritten messages from both soldiers and civilians stationed at the fringes of the Roman Empire. Composed in Latin, these documents encompass a variety of content, including personal correspondence, shopping lists, birthday party invitations, and even grievances about the weather. Notably, one of the most recognized tablets features a birthday invitation from Claudia Severa, the spouse of a Roman officer, extending an invitation to a friend, marking one of the earliest known instances of Latin penned by a woman. The tablets were remarkably preserved in waterlogged soil, which inhibited the decay of the wood. Upon their discovery, they provided a vivid glimpse into life within a Roman fort around 100 CE, highlighting the connections between soldiers, their families, and the local populace. Today, the Vindolanda tablets are regarded as a crucial collection of documents from the Roman era. In terms of AI's involvement, similar to other ancient writings, the Vindolanda tablets suffered significant damage. However, through the application of machine learning algorithms, AI is now capable of analyzing images of these texts and identifying patterns in the deteriorated writing. Consequently, should we uncover additional Babylonian writings, AI will facilitate their decoding with greater ease. Number 17, AI decodes 5,000-year-old tablets. 5 millennia ago, in the region of ancient Mesopotamia, scribes inscribed wedge-shaped characters into moist clay, thereby safeguarding the earliest written documents of humanity in a script referred to as cuneiform. In contemporary times, the vast quantity of these tablets, exceeding 500,000, has posed a significant challenge for scholars, with only a small portion having been translated. The advent of artificial intelligence has transformed this landscape. Recently, an innovative AI model created by researchers has achieved remarkable progress in interpreting these ancient writings. Cuneiform presents considerable challenges for reading, as a single symbol can denote various sounds or meanings based on its context. Additionally, many of the tablets in our possession are either damaged or incomplete, complicating the task further. Nevertheless, researchers have engineered an AI model capable of translating cuneiform directly into English, even reconstructing the missing segments of fragmented tablets by predicting the likely content of the original text. Over the past year, AI has facilitated the decoding and interpretation of royal edicts and other documents from 5,000 years ago. What a short span of time, solving centuries of experts, researchers, and scientists' dreams. Number 16, AI helps decipher an ancient language that defied translation for an entire century. From an early age, Jing Luo has been intrigued by the obscure and extinct languages of the world. Consequently, upon enrolling as a doctoral student in computer science at MIT in 2015, he chose to explore this enduring passion under the guidance of his advisor. Luo embarked on a quest to comprehend and potentially revive these lost languages. One of the scripts he sought to decode is Ugaritic, an ancient language dating back to approximately 1300 BCE. This language has long been associated with early Hebrew, yet the depth of research into it has remained limited. For many years, Ugaritic has presented a conundrum for scholars. Under the leadership of Professor Regina Barzilay, Luo and his team have created a neural machine translation model capable of interpreting Ugaritic with impressive precision. But what exactly is Ugaritic? It bears resemblance to cuneiform, which complicates its decipherment due to the absence of clear word separations and the presence of symbols that can convey multiple meanings based on context. Traditional approaches necessitated that experts painstakingly assemble these texts over many years. In contrast, Luo's AI model operates by identifying patterns within the ancient language and correlating them with known languages such as Hebrew. It employs a minimum cost flow technique, which essentially allows the AI to seek the most efficient method for decoding characters by drawing comparisons with our existing knowledge of other ancient languages. This model not only decodes individual words, but also discerns semantic relationships, providing scholars with insights into the potential usage of Ugaritic in daily life. Number 15. AI decodes broken Greek texts better than humans. There are numerous aspects where we worried AI might outpace us, and perhaps the ability to interpret and translate languages should be at the forefront. Google's DeepMind AI, named Ithaca, is transforming the way we analyze damaged ancient Greek texts, and it's doing so more effectively than humans. Drawing its name from the homeland of Odysseus in Homer's Odyssey, Ithaca was designed to restore fragmented inscriptions that date back thousands of years. Many Greek texts come from books or tablets that have deteriorated or broken over time, resulting in incomplete records that are difficult for humans to piece together. However, for artificial intelligence, reconstructing these texts is a straightforward task. By training Ithaca on more than 60,000 ancient Greek inscriptions and providing it with patterns of letters and words, as well as the age and geographic context of the texts, researchers have developed an AI model capable of accurately predicting and reading fragmented Greek. Ithaca's model can now fill in missing sections with an impressive accuracy of 62%, significantly surpassing human historians, who manage only about 25% accuracy on their own. When human expertise is combined with AI, that accuracy rises to 72%. This suggests that collaboration between humans and AI is essential for optimal results, just like the next video. Number 14. A 21-year-old uses AI to decipher text from a scorched scroll. The Volubilis Challenge represents an international competition aimed at deciphering the charred scrolls unearthed from areas devastated by the eruption of Mount Vesuvius in 2023. The inaugural winner of this contest was 21-year-old Luke Ferrer, who achieved a remarkable milestone by becoming the first individual in over 2 centuries to read a portion of a scroll that had been buried during the catastrophic event. The task of deciphering these scrolls is particularly daunting, as the carbonization caused by the volcanic heat renders them resembling charred logs rather than traditional manuscripts, and they disintegrate upon minimal contact. Nevertheless, through the application of artificial intelligence, Ferrer successfully identified a single word from the ancient text, phorus, which translates to purple. The methodology behind Ferrer's accomplishment involved the creation of an algorithm capable of detecting subtle crackle patterns within the scroll's structure, which corresponded to the ancient ink. This innovative approach earned him a reward of $40,000 for his identification of the first word. Current scholarly consensus suggests that these incinerated documents may have originated from a library within a villa potentially owned by Julius Caesar's father-in-law. Researchers speculate that there may be thousands more scrolls yet to be discovered, which could hold invaluable works of philosophy, history, or literature. Number 13. Google AI decodes ancient hieroglyphs. Google has established a significant presence in various domains, particularly in the realm of artificial intelligence research. Recently, the company unveiled Fabricius, an innovative AI-driven tool that revolutionizes the interpretation of ancient Egyptian hieroglyphics. Developed by Google Arts and Culture in partnership with specialists from Macquarie University, Ubisoft, and SciArc, Fabricius aims to facilitate the comprehension of hieroglyphics for both researchers and the general public. This tool employs machine learning techniques to analyze the 1,000 unique characters that constitute hieroglyphic writing, a script utilized by ancient Egyptians for millennia. Fabricius features 3 primary modes: learn, play, and work. In the learn mode, users can delve into the historical context of hieroglyphics and practice drawing symbols, which the AI subsequently evaluates for precision. The play mode enables users to compose their own messages and translate them into hieroglyphics akin to ancient emojis. Conversely, the work mode allows scholars to upload images of hieroglyphics for AI-assisted decoding, significantly expediting a process that previously required years of manual effort. This positions Fabricius as the inaugural digital tool leveraging artificial intelligence for the decoding of hieroglyphics. One can only imagine the astonishment of past Egyptologists and scholars upon realizing that a machine can now accomplish in minutes what once took them years. Previously, Egyptologists had to meticulously consult numerous texts to translate these ancient symbols. Fabricius now offers a more rapid and efficient method for analyzing and interpreting these inscriptions, enabling scholars to decode ancient texts at an unprecedented speed. Notably, this tool is open source, allowing it to evolve and enhance through contributions from the global research community. Number 12. Linear B, one of the most perplexing scripts of all time. In 1900, Sir Arthur Evans, a British archaeologist, encountered an enigmatic script while exploring the Palace of Knossos in Crete. This script is now identified as Linear B. Despite extensive research efforts, the decipherment of Linear B did not occur until after Evans's death in 1953. The breakthrough came from Michael Ventris, an English architect and autodidact in linguistics who successfully decoded the script. His achievement, however, was significantly influenced by the pioneering work of Alice Kober, a distinguished classicist who conducted a thorough analysis of the script structure. Kober was the first to suggest that the script exhibited inflection, indicating that words were formed from roots and suffixes. Over several years, she compiled nearly 200,000 note cards, meticulously identifying patterns and relationships among the signs of Linear B, thereby establishing a foundation for Ventris's work. Ventris's landmark discovery was facilitated by his recognition that certain words on the tablets corresponded to place names in later classical Greek, enabling him to align syllables and phonetic values. This revelation demonstrated that Linear B was not an obscure Minoan language, as previously believed, but rather an early variant of Greek. This finding has significantly altered the comprehension of ancient Greek history, extending the timeline of written Greek by several centuries. Although some tablets inscribed in Linear B have been deciphered, many remain partially untranslated. This is where artificial intelligence plays a crucial role. A collaborative effort by researchers from MIT and Google Brain has led to the creation of a machine learning algorithm that can translate the script with remarkable precision. The AI operates by recognizing cognates, words that share a common origin, and applying established Greek language structures to facilitate the translation of Linear B. The system was designed to detect specific patterns within the script's framework and has achieved an accuracy rate of approximately 67.3% in converting the script into contemporary Greek. This represents a notable advancement compared to earlier methods, which relied on manual processes that were labor-intensive and time-consuming. Number 11. AI helps in unlocking the secret of the Etruscan language. The Etruscans were a civilization that thrived in central Italy long before Rome emerged as a power. They remain one of history's most enigmatic cultures. Although they left behind numerous artifacts adorned with their unique language, our understanding of their writings is quite limited. This scarcity of surviving texts, coupled with the fact that Etruscan appears to have no close relatives among known languages, complicates our efforts to decipher their meaning. Recently, a collaborative effort utilizing neural machine translation models, similar to those that have successfully unraveled ancient scripts like Linear B, aims to unlock the secrets of Etruscan. These advanced AI models are designed to detect linguistic patterns within incomplete or fragmented texts, enabling researchers to hypothesize about missing words or symbols and draw comparisons with other contemporary languages. By processing extensive datasets of ancient inscriptions, these algorithms hope to reveal grammatical structures and vocabulary within Etruscan writing. Currently, AI is being employed to analyze a 2500-year-old steel artifact found near Florence. With the assistance of AI, we may finally uncover more about one of Europe's most mysterious ancient civilizations. Number 10. AI. Unlocking the secrets of the language of bees. The communication methods of bees may not be classified as ancient, yet they represent an area where artificial intelligence is significantly enhancing our understanding. For many years, researchers have been intrigued by the waggle dance, a unique behavior that bees use to convey information. Recently, a team of students from BYU has taken on the challenge of decoding this form of communication. Their research, which includes participants from fields such as computer science and biology, involves the creation of a specialized hive constructed with transparent plexiglass. By employing cameras to monitor the bees' movements, the students input this data into an AI system they have developed, which can interpret the waggle dances. The AI evaluates the angles and durations of these movements to accurately pinpoint food sources in relation to the sun's position. As noted by BYU professor Sean Warnick, this AI-driven methodology enables the team to uncover patterns and gain insights into the complex decision-making processes of bees, highlighting the remarkable intelligence of these creatures. Following their analysis of the waggle dances, researchers are also aspiring to create a robotic bee that can replicate these movements, potentially allowing us to communicate with bees directly. This is certainly a project worth following closely. Number 9. Researchers in Turkey use AI to read Hittite tablets. Researchers in Turkey are pioneering the use of artificial intelligence to unravel the secrets of ancient Hittite clay tablets, a groundbreaking initiative that is the first of its kind in the world. The Hittites, a prominent civilization in antiquity, produced thousands of cuneiform tablets that chronicle their political, social, and religious practices. Unfortunately, the traditional method of deciphering these texts has been labor-intensive and prone to inaccuracies. In partnership with Ankara University and the Ministry of Culture and Tourism, Turkish scholars have successfully digitized nearly 2,000 tablets from the Museum of Anatolian Civilizations and other institutions through high-resolution photography and 3D scanning techniques. These digital images are then processed by an AI system that analyzes and translates the ancient writings. Early results from the project are promising, with the AI achieving a remarkable 75% accuracy in translating the ancient script. With continued advancements, we may soon unlock the mysteries of this ancient civilization, all thanks to the transformative capabilities of AI. Number 8. The lost Iberian language. The Iberian language, once spoken by the early inhabitants of the Iberian Peninsula prior to the Roman conquest, stands as one of the most intriguing linguistic mysteries of the ancient world. Unlike many ancient tongues, Iberian does not have a direct descendant, such as Latin for the Romance languages, which complicates efforts to decode it. However, a breakthrough is on the horizon thanks to advancements in artificial intelligence. Researchers at MIT's Computer Science and Artificial Intelligence Laboratory, CSAIL, have created a cutting-edge machine learning algorithm designed to unravel the complexities of extinct languages like Iberian. This innovative AI model operates without the need for a closely related modern language. Instead, it examines sound change patterns across languages, linking Iberian words to phonetically similar terms in languages we understand today. This approach has already begun to overturn long-standing theories, including the notion that Iberian is closely tied to Basque, indicating that these languages may not share a direct relationship. By employing sophisticated linguistic methodologies, this technology not only tracks the evolution of language sounds, but also holds the promise of uncovering the meanings of words, even in the absence of contemporary equivalents. Number 7. AI helps unravel the history behind the Dead Sea Scrolls. The Dead Sea Scrolls stand as a monumental archaeological achievement of the 20th century. Unearthed between 1947 and 1956, in the vicinity of the Dead Sea, these ancient scrolls, dating back 2,000 years, still hold many secrets. What we do know is that they encompass biblical texts, commentaries, hymns, and community regulations crafted by an enigmatic group. In a groundbreaking development, researchers have started employing AI technology to delve deeper into the mysteries of the Dead Sea Scrolls. One of the most significant discoveries made through AI analysis is the Great Isaiah Scroll, recognized as one of the longest and most well-preserved among the collection. This innovative technology has revealed that the scroll was likely transcribed by two separate scribes. By utilizing sophisticated pattern recognition methods, AI meticulously examined even the smallest nuances of the handwriting, including the thickness and curvature of each letter. This extraordinary attention to detail enabled researchers to identify variations that would otherwise go unnoticed, thereby confirming the involvement of two distinct scribes in the creation of this remarkable document. On to another unlocked literary we go. Number 6. AI helps us learn about one of the biggest literary finds in Constantinople, the Archimedes palimpsest. The Archimedes palimpsest is an ancient manuscript over 1,000 years old, featuring previously undiscovered texts by the renowned Greek mathematician Archimedes. Since its unearthing, it has been celebrated as one of the most significant literary discoveries in Constantinople. For those unfamiliar, palimpsests are documents where earlier writings have been erased to allow for new text, yet traces of the original content remain visible. In contemporary times, artificial intelligence and cutting-edge imaging techniques are aiding researchers in uncovering these obscured writings. By employing multispectral imaging and AI, scholars can meticulously peel back the layers of text, exposing Archimedes' original works hidden beneath. So far, we have revealed remarkable insights from Archimedes on topics such as infinity, geometry, and a method strikingly akin to modern calculus. Imagine the potential discoveries that AI could still unveil regarding the brilliant writings of Archimedes. Number 5. Chinese oracle bones decoded by AI. Oracle bones are ancient artifacts that feature early Chinese characters and were utilized for divination practices during the Shang dynasty. Despite extensive efforts over the years, the inscriptions on these bones have largely remained a mystery. However, recent advancements suggest that we may be on the verge of unlocking their secrets. Researchers from Xi'an Jiaotong Liverpool University and Renmin University have created an innovative deep learning tool named Bone2V. This tool not only analyzes the inscriptions, but also assesses whether the ancient scribes were left-handed or right-handed by examining the angles, pressure, and stroke patterns present in the writing. The AI is capable of identifying subtle physical traits of the writing style. This AI-enhanced research significantly aids archaeologists in examining the 160,000 oracle bones that have been unearthed to date, providing unprecedented levels of efficiency and accuracy. Recently, several bones have been identified with simple symbols that denote words such as moon, river, grass, divination, tears, and others. Number 4. AI discovers a beautiful lost hymn in ancient text. In 2023, a team of researchers unveiled an innovative AI system designed to interpret fragments of ancient Babylonian texts. This groundbreaking model, referred to as fragmentarium, holds the potential to reveal some of humanity's earliest narratives, including the renowned Epic of Gilgamesh. Created at Ludwig Maximilian University, this AI technology is capable of analyzing thousands of fragmented clay tablets, effectively reconstructing cuneiform inscriptions that have long posed challenges for human scholars due to their deterioration or loss over time. The AI achieves this by examining patterns across a vast array of text fragments, enabling researchers to piece together portions of Babylonian literature. Among the notable findings is a remarkable hymn that evocatively depicts the arrival of spring in Babylon, celebrating the rejuvenation of nature with imagery of rivers nourishing the plains and grains flourishing in the fields, symbolizing the prosperity that accompanies the season's renewal. This discovery is particularly noteworthy as it introduces a previously unknown genre of hymns dedicated to cities within Babylonian literature, a form that has remained lost for millennia. The efficiency and accuracy of AI have significantly expedited this process, which would have otherwise required scholars decades to complete, by digitizing over 22,000 text fragments. Number 3. Decoding the mysterious Voic manuscript. In 1912, Wilfrid Voynich, a Polish-American book dealer, stumbled upon a manuscript written in an undeciphered language. This peculiar book is adorned with illustrations of plants, celestial charts, and human figures depicted in unusual ways. Dating back to the early 15th century, it has resisted all attempts at definitive interpretation despite extensive research. Today, it is famously known as the Voynich manuscript, regarded as one of the most enigmatic texts ever discovered. The manuscript features illustrations of non-existent flora, zodiac signs embellished with enigmatic details, and intricate diagrams that appear to illustrate various processes or cycles, all of which remain open to interpretation. The text itself, written from left to right, employs a script that bears no resemblance to any known language, past or present. This has led to theories suggesting it could be a complex code, a lost language, or a significant manuscript that remains beyond our comprehension. Such possibilities can be quite unsettling. Some have speculated that it might serve as a medieval medical guide, while others propose it could relate to alchemy or philosophical ideas. Numerous theories about its purpose and authorship have emerged over the years, yet none have been substantiated. The identity of the author remains elusive, with candidates ranging from the 13th century philosopher Roger Bacon to Leonardo da Vinci, though none of these claims have been verified. The Voynich manuscript continues to perplex scholars, cryptographers, and historians with its unreadable text and bizarre illustrations. However, recent advancements in AI technology are starting to illuminate this 600-year-old mystery. Researchers from the University of Alberta, led by Greg Kondrak and Bradley Hauer, have employed AI to analyze the manuscript's language, utilizing a system capable of recognizing patterns across numerous languages. The AI proposed that the text could be encoded in a form of Hebrew. Upon closer examination, it was determined that approximately 80% of the words in the manuscript corresponded with entries in a Hebrew dictionary, albeit in a jumbled format that complicated interpretation. For instance, one of the initial translations by the AI resulted in the phrase, "She made recommendations to the priest, man of the house, and me and people." This translation lacks clarity, and while it does not provide a complete understanding of the manuscript, it represents a promising beginning. It raises the possibility that the Voynich manuscript might be decipherable, though doubts linger. Many experts remain cautious, recalling that earlier efforts to decode the manuscript have pointed to other languages such as Latin or Arabic. Nevertheless, the introduction of AI offers a thrilling new avenue in this enduring enigma. Researchers are currently enhancing their algorithms, aiming to finally unravel the mystery of the Voynich manuscript. What are your views on this book? Do you believe it is a significant manuscript containing the secrets of ancient civilizations, or merely a hoax from the 13th century? Share your thoughts in the comments. Number 2. AI model can translate dead languages in mere seconds. Akkadian. Have you come across this ancient language before? It stands as one of the oldest languages in the world and is also known for its complexity. Originating in ancient Mesopotamia, Akkadian was inscribed using cuneiform, a unique writing system featuring wedge-shaped symbols etched into clay tablets. While there exists a vast collection of untranslated texts, only a handful of individuals possess the ability to read Akkadian. Fortunately, advancements in AI are set to change that. For many years, translating Akkadian involved a tedious process of transliteration into Latin characters before rendering it into English. Now, with the advent of a new AI model, we can streamline this laborious task. Imagine it as a version of Google Translate, but specifically designed for ancient languages. Remarkably, this model boasts an impressive 97% accuracy rate for Latin transliterations and performs well in direct English translations. However, it does face challenges with literary or creative texts, occasionally yielding inaccurate results. Nevertheless, when utilized alongside scholars, this AI has the potential to significantly enhance our understanding of the Akkadian texts that have survived through the ages. Number 1. Decoding the language of plants. In 2023, several startups have turned their attention to a unique area of interest, the communication of plants. Companies like Citia are developing AI models designed to interpret the subtle cues that plants emit in response to environmental changes. These cues range from electrical signals in their roots to ultrasonic sounds produced when they experience stress. In essence, plants do communicate with one another. An AI model can analyze how plants react to various factors such as light, soil quality, and temperature. You can think of this AI as a translator for the emotional state and well-being of plants. If commercialized, this technology could significantly benefit the agricultural sector. It would enable farmers to optimize the timing and method of resource allocation, such as water and fertilizers, leading to more efficient and sustainable farming practices. However, this technology is still in its early stages. Initial trials have demonstrated that the system can decrease energy usage in greenhouses by as much as 30% while maintaining crop yields. In the coming years, we may see an AI model capable of truly understanding the language of plants, allowing us to care for them more effectively. What other groundbreaking developments in AI are you looking forward to? Beyond the ability to decode ancient languages, what do you believe would be the most significant application of artificial intelligence? Write your thoughts in the section below. Hit that like button and subscribe to the channel for more fascinating videos.